Morning all. I hope you're doing good today. We're ready to finish up this section 4 on the properties of logarithms. I'm going to show you today how to change the base so that you can do even more different types of problems by hand, but I'm also going to show you how to change the base so that you can use your calculator to help you out on these things. Remember, I said there was no button on there that can change our base, but there is a logarithm button, and we'll get to that hopefully very shortly. Okay, so here's where we start. We start with the change of base formula, because the change of base formula allows us to make more convenient bases. Okay, what you want to consider is what base is going to make more sense with the two numbers 27 and 81, which power might be in common for those two numbers. So for example, 27 and 81 are both powers of 3. So if we consider that 27 is actually 3 times 3 times 3, or 3 to the third, and 81 is actually 3 times 3 times 3 times 3, which is 3 to the fourth power, and we have that common base for both of those, that common base being our C, or being 3 in this case, is going to be very helpful for rewriting this and solving this without any calculator. So what you do is you rewrite it so that you have the log base 3 of 27 over the log base 3 of 81. This is what our change of base formula does for us. So when we consider that log base 3 of 27 is 3 to the third power, so in other words, the answer to log base 3 of 27 is 3. And then after that, we consider that log base 3 of 81, 3 to the fourth power is 81. That gives us our 3/4 as far as being our answer to that question without the use of a calculator. So it's a very nice way of solving that logarithm. Okay, so let's check another one just to make sure you got it. Try to get ahead a little bit, and if you understand it, then great. And you look at these two and you think about what number would be a good common base for that. And you can think, well, wait, this is a power of 2 and this is a power of 2. So we're going to choose 2 as our common base. Log base 2 of 32 over log base 2 of 8. 2 to the fifth power is 32. And 2 to the third power is 8. So once again, a pretty nice slick little process there to help evaluate logarithms by a change of base that makes your work so much easier. And these are almost simple enough that you can almost do them in your head if you remember the process. However, write it down anyway so that you have something to go on and look back on, and like make your brain get used to seeing it. All right. Now here's a neat little thing. We just did this one a minute ago, and we found out the answer was 3/4, and that was simple enough. But I want to show you with that example how to do this purely on your calculator, because another common base that will always work is base 10. And base 10 is actually covered on your calculator. This logarithm button right here is log base 10, because the implied base for any logarithm is 10. So even though 3 would be most convenient if you're doing it as far as in your head, log base 10 allows you to do this in a calculator. So what I can do is I can do log base 10 of 27 over log base 10 of 81. And I can do that strictly 100% in the calculator. Log base 10 would be hard by hand, but in the calculator it gives you a new tool. So log of 27 divided by log of 81. And when we do that, there's your 0.75, which is the same answer that we got a minute ago by doing it by hand. And yes, I like the other one. Like this problem, honestly, I think doing by hand is a little bit easier. But there are some problems that you need to turn it into log base 10 because it's really very, very difficult or near impossible to do that by hand. So for example here, log base 5 of 36, there's no nice, common, convenient power that is working for both of these. So here your recourse is to say, well, I'm just going to turn them into log base 10s, log base 10 of 36, log base 10 of 5, and let the calculator do the work. Okay, so log of 36 divided by the log of 5. And you get approximately 2.227 or approximately 2.23 if we use our rules of rounding, 2.23. Okay, so you can change the base to that thing that the calculator actually can handle, and that's super, super, super convenient. So time to drag these calculators out so you can do these type of problems. Okay, what I'd like you to do right now, and you can still count it as watching the whole video if you just do these real quick, throw them in your calculator, make sure that you can do them, and then you can skip ahead, but I'll talk it through for those that need to hear it one more time. Okay, log of 4, log base 4 of 18 would be log of 18 over log of 4. And this is calculator work, so we can do log of 18 divided by log of 4 2.1 or 2.08, and so on and so forth. This would be log of 15 over log of 2. Log 15 divided by log of 2. And these are all log base 10s, but this change of base makes that work out very nicely, not 3.91 when we have that answer. So, and so on and so forth. So you can do this log of 6 over log of 3. These do not cancel out, by the way. This is not log times 6, log times 3. Put it in your calculator just like we did it the last two. And this one is log base 14, log of base 10 of 14 over log base 10 of 28. And we don't even usually say the log base 10. It's implied if there's nothing there and we don't say it. So 0.79. Calculator work, so that's good. Your calculator can do a whole lot for you once you've learned what it's for. Okay, all right, moving right along. We do need to do some more simplifying from part 1. So just to look at a few more of the complicated ones, and I did notice a couple of you needed to see more of these anyway, so killing two birds with one stone here. We're trying to bring it into a single logarithm, so you can first of all look for things that are common factors, because that's always a good thing when you're trying to put stuff together. 1/4 is a common factor, so I want to start off by just factoring out that 1/4. Okay, now we have a logarithm with a common base, and as long as you have a common base, okay, this plus can turn into the log base 3 of 2 times x, because the plus is the one that turns into a times, if you remember correctly. Hopefully you have that sheet next to you that has all of those properties of logarithms. So this turns into this. Then you can take this 1/4 that's out here because it's a product, so the product turns into an exponent when we look at it in terms of logarithms, but it's the whole thing that you took the logarithm of. So then this as a radical is the fourth root. So here's our simplified logarithm when it all comes down into one logarithm. So you're looking for things in common. You're looking for applying the properties of logarithms to that, because we've got those properties. Remember, if you have a plus, you're thinking, well, that's going to turn into multiplication. Remember, it's all based on exponents because that's what logarithms are. If we had a minus, it would turn into division. And when we have a number out front, that actually turns into an exponent. Okay? Watch that over and over again if you need to. Here we have this one. This is 5 log base x of z, not 51 og. It's 5 times the log of x, log base x of z. This part seems to be acting separately from this part, and it is, so we want to evaluate them separately. We're writing it as a single logarithm. We already have this factored out, but what we need to do is look for other ways we can simplify. Inside the parentheses, we have this plus, so we can turn this, because they have the common base, turn it into a multiplication. Still have done just this one little thing over here, because this number being out front can be turned into a power. Okay, it turns into a power of what you're taking the log of. This then can also become a power. Okay, so it's a power of this right here. Now we've got a common base, and you have a minus sign, and the minus sign can turn into division when you're bringing it together. Or you can do that first, or you can simplify this first. It makes no difference. So to the half power, square root of 9 is 3, square root of y is y, and then the minus can turn into its division problem. So you can either do this step first and then simplify, or you can simplify first and then do this step. So once again, your pluses turn into multiplication because we're thinking exponents. Your minuses turn into division. Once again, we're thinking about properties of exponents. They're very closely related to logarithms. And your multipliers, out front, get turned into exponents because they're powers. Okay. All right, one more. This one, if it says to expand, you have to do all those things backwards. So we're going to want to start thinking about all the roots we need to turn into powers. So that's a half power. Then we have this is all attached together. In order to detach it, we can bring this half down front. Then we've got the 2 and x attached together in a grouping symbol, but this grouping symbol turns into a minus if we expand it. But be careful, because this half is multiplied times all of it, so we need to use some parentheses. So this turns into this. We then have a product hiding in here. Okay, there's one last. You have to look for everything that can break down. So this product turns into a sum. And then finally, in order to make it fully expanded, distribute this half back into everything. So we have this. So there you have it. We reviewed the applying of the properties of logarithms, and we learned a little something new about how to get your calculator to do this process for you. And we're moving right along, and what I have done for next week, I've consolidated a couple of things to make it work a little bit better. Based on our new Take a Breath Wednesday, I've reduced the amount of problems considerably for sections 5 and 6, so we can get what we need to get and just kind of move on with that. So I'm in the process of solidifying the plan, but if you look at the assignment sheets, you'll find that I've crossed out some, and you'll see that, yeah, I really did cut out a lot of problems. and made it into one assignment, 95 and 96, not on 2 different days as big assignments, but 95, 96 combined since they're all in one section. So you'll have that next week. But for now, work on assignment 94, get that out of your road, and have a great weekend. Be ready to turn that in at the beginning of the period on Monday. God bless you, and I'll see you hopefully sooner than later.